Good morning, students. This class we will deal about orbitals and the shapes of orbitals. An orbital is a mathematical function which depicts the wave-like behavior of an electron pair. Orbitals are also referred to as electrons or atomic orbitals. Atomic orbitals are the three-dimensional structure or the region of the space around the nucleus of an atom. The atomic orbitals allow the atoms to make covalent bonds. S, P, D, and F orbitals are the most commonly filled orbitals. As defined by the Pauli's exclusion principle, only two electrons can be found in any orbital space. Note, there is a region where the probability of finding the electron is zero. It is called a node. Nodal plane, a plane passing through the nucleus on which the probability of finding an electron is zero, is called nodal plane. The number of nodal planes in an orbital is equal to azimuthal quantum number. Spherical or radial zone, a spherical surface within an orbital on which the probability of finding electron is zero, is called spherical or radial node. K, L, M, N, O, P, and Q shells. Atoms tend to assume the most stable configuration and the lowest energy level possible. For that reason, the electron shells in an atom are usually filled in a strict order, starting with the lowest energy level. Each of the electron shell N1 to N7 or K to Q can hold a maximum number of electrons determined by the formula 2n square, where n is the electron shell number. So N1, which is K shell, which has 2n to the power 2. So it will be getting 2, and 2n square, if it is 2, it will be having 8 electrons, which is contributed. Types of orbital. S orbital. For S orbital, the azimuthal quantum number is 0 and the magnetic quantum number m is 0. Hence, the S orbital have unique orientation in the space. That S orbital corresponds to spherical shape with the atomic nucleus at its center. For every value of n, there is one S orbital. Its radius depends on the value of n. As the value of n increases, the size of the S orbital also increases. It has no nodal plane, so it has a spherical shaped structure. P orbital. For P orbital, azimuthal quantum number L is equal to 1 and the magnetic quantum number M is equal to -1, 0, +1. Hence, the P orbital have three orientations in the space. The P orbital corresponding to dumbbell shape with the atomic nucleus at its center. The p orbitals have two lobes directed on the opposite sides of the nucleus. P orbitals are oriented in the three different directions along x, y, and z axis of the usual coordinate system. These orbitals are designated as px, py, and pz orbitals. P orbitals have one nodal plane. So x, y, and z. D orbital. For D orbital, azimuthal quantum number is 2 and the magnetic quantum number is -2, 1, -1, 0, +1, +2. So hence D orbital has 5 different orientation in space. Thus D orbital corresponds to 4 dumbbell shaped orbitals with atomic nucleus at its center and one dumbbell with donut shape, which is dz square. D orbital has 2 nodal planes. So D xy and dx square minus y square, dxz and dyz and dx square. F orbital. For F orbital, the azimuthal quantum number is 3 and magnetic quantum number is -3, -2, -1, 0, +1, +2, +3. Hence, F orbital have 7 different orientation in space. F orbital has complex shapes with atomic nucleus at its center. F orbital has 3 nodal planes. So fxyz, fx x square minus z square, fx z square minus y square, fz x square minus y square. Along with that, fz cube, fx z square, fyz square, fx x square minus 3y square, fy y square minus 3x square, fxyz and fz x square minus 3y square. Thank you.